now. And I had one quick announcement before you get started. I did want to let everybody know, Brad and I have to submit midterm grades. So at least for BUDA 450, midterm grades have to, well, for everybody, midterm grades have to be submitted by noon on Thursday. For BUDA 450, the goal right now is going to be to include assignment 1, 2, and 3 grades in that midterm grade. I wouldn't stress about it because, again, we're doubling your top 3 assignment grades, you know, the point value of your top 3 assignment grades. We haven't gotten through our midterm, so don't be stressing out about your grades. But I did want to let you know the plan as of now is going to be to include assignments 1, 2, and 3 in that midterm grade to be submitted Thursday at noon, which means your assignment 3 grades for BUDA 450 at least will be posted by then to eCampus as well. So you'll be able to see that and see the feedback. So just want to let you know, and the plan is still to release the midterm exam this Friday, so that you all have a full week to complete that. And if you want to get started on it over fall break, you're welcome to do so. So that's all I got for today, Brad, on that.
And I'll just add, anytime we talk about grades, remember the 2 rules: show up, do the work, right? Let us worry about the grade. The grades are a point in time evaluation of you all. And I know that's easier said than done, right? Don't worry about your grade. I can say it because I'm sitting on this side of the table, right? But I'm dead serious about it. The things we're asking you to do, the things you guys are doing, you're pushing yourselves, okay? This is an elective class. This is an elective minor. I know that. You guys choose to do this. You choose to engage in it. It is not lost on either of us that you do that, okay? But what are the 2 rules? Show up, do the work, right? You're doing the work, you're putting in the time, you're coming to lecture, you're watching the videos, you're doing all that stuff, right? Then you're going to be okay. I think module 3 shows kind of a fair assessment of, we're going to grade you on what we cover, right? Module 4, week 4, whatever the probability thing we just finished was, will also show you, we're going to grade you on what we cover, right? We're not trying to trick you here. And you'll see it more and more as we go through regression. Y'all good with that? If you have any questions, any concerns, you're more than welcome to come see either of us. You can yell at Kristen too. Don't yell at Kristen, yell at us if you're going to yell. Kristen's way too nice to be yelled at. So, but if you want to yell at somebody, yell at Catherine or I. Actually come yell at me. And we'll have a great discussion about that. But it's also one of those things, we're here to help you, okay? So if you're struggling, you feel like you're alone. That's the one thing I hate about online classes is there's times you can feel alone in this stuff, okay? Sitting there banging your head off a wall. 20-minute rule. Something doesn't work the way you think it is. Don't get mad. Don't throw your computer. Computers aren't meant to fly, okay? Step back. Say, hey, I should probably drop them an email and ask this question. And I promise you, we'll respond as soon as we can. Y'all good with that? Again.
Yeah. One thing to add, because I've had a couple students reach out, freaking out a little bit about the coding. You know, a lot of you have not coded until this class. I learned how to code like over 3 years ago, and I still Google things all the time. So don't think that you need to have gotten this in a matter of 3 weeks. You know, and not only is Google a great resource when you're trying to figure out how to code something in R, but Brad and I and Kristen are also here for that purpose. So like Brad said, the 20 minutes in, your out rule totally applies. We are here to help beyond just the lectures. So don't get discouraged when you're thinking, oh my gosh, I'm not proficient enough in coding in R. It's okay. It's really okay. And Brad's been coding even longer, and I know he also has to look stuff up frequently.
Yeah, no, you're never going to memorize all this. But the other thing is, remember why we're asking you to do these assignments, right? Concepts are great. Concepts are wonderful. Concepts don't get you paid. That's as honest as I can be with you guys. Like, if you're doing this for any other reason to help it look good on your resume, to get a job, to understand this stuff, we need to have a different type of conversation. But the reason we ask you all to do this stuff is so when you throw this on your resume, it's real. Because the other thing you guys have to understand is we have to maintain degree quality programs, right? And if somebody's throwing, I know this, I have this on their resume, and they don't, you don't think I hear about it from hiring managers? So this is something for me and for y'all to protect the kind of quality that we do here. But the other thing is, you're not going to get experience. You're not going to understand this stuff if you're just looking at it. You've got to touch it. You've got to feel it. That's the reason you'll see us start to move away from test banks and question banks when we can, because I want you all to show the ability. I want you all to learn, and you learn by doing in these situations. Y'all with me on that? And that's a great place to start our conversation for today. So here's how this is going to work. Catherine, do we have a visitor coming on Wednesday still?
Yes, first thing Wednesday.
Yeah. So do you want to fill them in on that real quick before we jump into this?
Sure. Yeah. Tara St. Clair is the director of the Encova Center. She's going to be joining us at the beginning of class on Wednesday, just to talk about the business plan competition. So, some of you all might have some great ideas, or want to become a part of a team that can help to solve some problems with some great ideas. And especially in this line of work, there is always a need for your skills to be applied. So she's going to talk a little bit about the business plan competition, the very beginning of class, and then we'll use the remainder of the class just to go over kind of our expectations for the midterm, and what you all can expect out of the midterm, because by then Brad and I'll have it somewhat outlined in terms of what our expectations are going to be for you all. So again, she'll be joining us at the beginning, and then we'll cover expectations for the midterm afterwards.
And this would normally, if we were in person, this would normally be on my rant of be here on time, like best foot forward. We have a visitor coming in, like the lecture you'd get in like elementary and middle school, right? When you had the principal come visit. That's what this is for us. So you guys show up, listen to Tara. She's awesome. But the other thing is, part of the reason we want to bring her in to have this conversation is, again, your all skill set is always in demand, but it's one of those things. It goes back to the reason we're teaching you to code and program. Is because if you have a good idea, we want you guys to be able to test it, develop it, and go look at it. Y'all with me on that? That way you don't have to rely on other people to do proof of concept work for you. That way you can say, yeah, this is a good idea. Now go pay a professional software developer if you want to create something that is like platform-esque. All right. But to get an idea off the ground, you guys will have the skill set to do that hopefully by the end of the next couple of classes that you all hang out with us for. Okay. So with that said, let's talk about some advanced stuff today. And the way we're going to do this, I kind of went back and forth on it a little bit over the weekend. And then I decided, no, gut instinct's normally right, because you guys told me you wanted to review some stuff. Okay. So we're going to jump into the stat reminders document, because this is the stuff to me you should have covered at the end of a intro class. And if I had to guess at the end of an intro class, you guys probably caught senioritis on me. You guys probably were like, I'm done with stats. I don't want to deal with this anymore. Like, just get me to the final and get me out of here. And so you focused more on your grade than actually understanding this stuff. And so what I want to do now is I want to spend some time on what is regression, okay? And why is regression important from an introductory level? And then what we're going to do when we come back next week is we're going to hit it again, okay? We're going to hit it again. And what do I mean what we're going to hit it again? All right. What do I mean when we're going to hit it again? Is we're going to do an advanced version of a similar lecture, okay? So we're going to introduce introductory concept, and then we'll come back and say, okay, here's how we do it at an adult level, all right? I'm going to do the explain it to me like I'm 5 today, give you guys some feel for what's going to happen, give you guys some basics, and then we're going to come back and say, look, now you're doing this professionally. Now you're getting paid for this for a living. You better understand some things that are going on behind the scenes. Y'all with me on that? So I'm going to be talking about introduction to regression for about 4 lectures is my goal. All right. 2 prior, 2 after. And when I say prior, 2 prior to fall break, 2 after. We're going to move, I won't say quickly through this because I'm not going to focus on code this time. What I'm going to focus in on concept and letting you guys visualize some data. Y'all with me there? We'll hit code the second time through it. Everybody good? Questions, comments, concerns? You guys are crazy. Anything anybody needs to get off their chest right now? Y'all good? All right, let's go to work for a little bit. Now, this starts on page 135. And we're going to start off with a movie example because, during COVID, I'm sure everybody fell in love with Netflix or Amazon Prime or Hulu or Apple TV. Big fan of Ted Lasso, by the way. Highly recommend. But what we want to start with is something that everybody understands, okay? So the first question is, how well does the production cost of a movie predict how well it will do in the box office? Data courtesy of Houghton Mifflin was collected from a random sample of 10 Hollywood movies. So what we're going to start doing is we're going to start looking at data as a complete observation. When I say a complete observation, this is movie 1, this is movie 2, ... We have the box variable, which is first year box office receipts in millions. So the first year for movie 1, they made 85.1 million. Production costs in millions, 8.5 million. Promotional costs, 5.1. And it was a book. So the book sales made 4.7. So not too bad for production costs, promo costs, and book costs to make 85.1 off of it. Not a bad day, right? Now let's take a look at the next one. It says 106, 12.9, 5.8, 8.8. All right. And I'm pretty sure this URL is dead now, but I can find that data somewhere. Now, the goal of regression, okay? The goal of regression, look at the question we just asked. How well does the production cost of a movie predict how well it will do at the box office? So all I'm looking for is the relationship between prod and how it informs box. Y'all with me on that statement? All right, the goal, explore the association between two quantitative variables. Quantitative means numbers. Everybody's good with that statement, right? All right, we want to look at production cost and box office sales. Now, there's an approach to this, and you are going to hear me hit this over and over again so much, you are going to be sick of it. There is a process to this. I am going to show you my process. I am going to show you the process that Catherine and Kristen started with and developed their own process off of. Everybody has their own process. You learn it one way first, and then you figure out how you're going to approach it, okay? Here's where you all think stats is actually a math class, and I'm going to tell you it's as much of an art as it is a science, and that's going to bother the living daylights out of you. I'm sorry, I apologize, that's the reality of the situation. There is no do step A, do step B, do step C. Well, it's do step A. Maybe you try step B now, but you could maybe try step C or D. What you're going to see as we go through this, there's a million ways to do it. What we're actually doing is trying to solve a problem. What's the problem? Can we define the relationship between two quantitative variables? All right. So every time we go through it, it might look slightly different, but we're going to highlight the process. The two steps of the process I want to start with are get to know the sample data using both graphical and numeric summaries. And then use sample data to make inferences about true population relationship. Remember, we talked last time, there's two reasons we do anything, especially in regression modeling, right? You build regression models. We find these relationships because we want to predict what's going to happen, or we want to be able to say these two things are related and it's this.
Sample class because he's getting allergy tested.
Awesome. So now, next thing, what we're going to do is we're going to explore some data here. And what are the graphical summaries we're going to look at? And I'm going to show you the most life-changing plot and type of plot you're ever going to see, okay? I mean, guys, this is really innovative. It's called a scatter plot. Don't know if you've ever heard of it, all right? You've been looking at them, I guarantee, since spring 2020, because that's how everybody's modeling COVID, all right? I'm not going to make this class about COVID. This is the one time a day I get to talk about something else, and I'm super excited to always talk about other things. So we're not going to relate it back to that, but you've been looking at graphical summaries this entire time if you've been trying to stay informed on data, okay? The scatter plot, I know you guys talked about a little bit, but just as a reminder, is a graphical tool used to display the relationship between two quantitative variables. Ooh. Constructing a scatter plot, you need an x-axis and a y-axis, which is pretty true of any plot you'll ever build in your life, which is great. And then we need to represent each observation with the point at its xy coordinate. Now, what's that look like? These are scatter plots. All right, these are scatter plots. Ignore the numbers at the top for a second. Let's start with the upper left-hand plot. The upper left-hand plot, we have an X variable and a Y variable. They are both quantitative. This represents one of the data points. All right, this would represent box office and production costs, box office revenues and production costs of a single movie in that data set we just talked about. Everybody good with that? Here's another movie. Here's another movie. Here's another movie. And what we do is we look for overall trends in the data. Take a look at that top left-hand plot, and without using any technical terms, tell me what's happening.
It's going up as you're moving left to right.
It's going up as you're going left to right. So what we're saying is as X goes up, Y goes up is the overall trend. Y'all good with that? Now, in a more defined setting here, we would say as whatever variable this is increases, Y increases, and you walk away from the plot for a minute. That's what they need to take away, right? All right, let's go here. What do you see? Same way, describe it. Let me give you some help. As X increases, what happens to Y? It go up or down?
Down.
Overall trend is it goes down, right? Telling you rocket science today, y'all. These graphs are really, really important though. Why? Walk into a boardroom and have only numbers on this stuff and watch what happens. One of the things we're going to hit over and over and over and over is how do we interpret, how do we explain? I'm going to show you some cool tools as we get further through this called effects plots, which what it's going to do is allow you to visualize and quantify really complex relationships in data. All right. You guys are going to learn this a little bit different than I guarantee anybody in this college has learned it before. And I almost guarantee anybody at this university has learned it before. Because what you have to realize is the data analysis part, I can teach anybody to do. What makes you all different, and the reason I like teaching here and I like teaching you, is you're going to be able to communicate the findings better than anybody else. If you walk out of this class and you can't do that, I have not done my job. Catherine has not done her job. All right. That's our big thing. I will hammer that point till the end of time. Y'all with me on that? So when we start talking about what interpretation means, and I'm walking through this and I'm kind of joking and having fun, don't think it's not because I don't value it. It's because I'm looking at a lot of black boxes. Okay. This is one of those things. Get comfortable talking about it. And this is listen, you guys are never wrong. I'm asking you questions like, what do you see? Tell me what you see. Because if you're not seeing the right thing, I want to help you fix it. Y'all with me on that? Talk to me what you see here. Don't look at numbers, look at the plot. Does it look like anything's happening between X and Y to you there? Maybe a little bit, not really. Remember, there's times you'll see what you want to see, right? Look at how I've put this right below. Now I'm tricking you here. Look at how I've put this right below something that has a positive correlation with it that's really strong, or a positive relationship that's really strong. This as X goes up, Y goes up stuff, right? And then look at how your eyes start to see something that looks like that. Y'all with me on that? Ain't much going on here. All right. Now, if we describe this one, what we say is there's a nonlinear trend. What it means is it's not a straight line. There's a curve that happens. Y'all with me on that? So these are scatter plots. Now, like I told you, what we look for is we look for an overall pattern. Is it linear? Is it curved? Linear means does a straight line go through it? All right. Strength. How closely do the points follow a pattern? We say those points are pretty tight around a single pattern. Would you guys agree with that? There's not much variability. It doesn't change a whole lot. Here we say that's a little bit bigger, right? Now, people are going to want you to use exact terms. All right. People are going to want you to say, it's strong. It's yeah. We'll talk about that here in a minute. Okay. Direction. Do the variables have a positive or negative association? And that's where I want to start. Two quantitative variables are positively associated when high values of one of the variables tend to occur with high values of the other. High is a relative term. Positive association means if X goes up, Y goes up. Y'all with me on that? When I say positive, it's this left to right. If X goes up, Y goes up. Y'all good with that? So if that's positive, negative probably means if X goes up, Y goes down. All right. If X goes up, Y goes down. So it goes top left to bottom right. Y'all with me on that statement? This is what we would call a no association. Just looks like randomness. If X goes up, I can't tell you what Y is going to do. I'm guessing. Y'all with me on that? Now, remember the probability statement I told you to remember. Independent, right? Meant two things were not related. Y'all agree with that statement? They can occur together, but are not related. I told you that was a really important concept, right? I did my hand flash thing and was like, when you're fast forwarding through the video because you don't want to hear me anymore, you want to find the important stuff, you can see that, right? Here's this. Look at this. We call these variables independent, just like we said events were independent. Didn't mean they couldn't occur together, means they were not related, right? I should have production costs of the movie if I'm going to have box office results. Y'all agree with that? Those two things can occur together. That just doesn't mean one is informative of the other. There's no guarantee. That's what independent means. And that's how we're going to use it for the rest of the term. Y'all with me on that? And I'll hit that again. I promise that ain't a concept that's going anywhere. Most of regression analysis, like the actual statistics behind regression, when we're not doing prediction, is about proving or disproving something is independent of something else. Y'all with me there? All right. Now, the other thing I need you to understand is outliers. All right, outliers. Now, there's a book called Outliers. This ain't that. Outliers in general. Are there any unusual points that fall outside the cloud of data points? Look here. Look at all those data points. Anything look weird to y'all? Anything look like it doesn't follow a trend? That one looks a little weird to me. Y'all agree with that? That one's different. Play the Sesame Street game. Which one of these things doesn't look like the other? Which one of these things are not the same? Yeah, my 3-year-old has me schooled on that pretty well. But what we're looking for is outliers like that. Now, outliers have a specific definition in regression. We'll get to this again. This is one of those things I want to say now. Outliers in regression means things that do not follow the overall trend. Okay. It doesn't mean a big value. It means, does it follow the trend or not? Y'all with me there? All right. All right, let's keep rolling. Let's take a look at another example. Is there an association between Olympic winning times for the 200-meter dash and the year in which the Olympics took place? The following is a partial data set of Olympic winning times in seconds starting in 1908 and ending in 1996, where year is the number of years since 1990 and a time is the Olympic winning times for the 200-meter dash in seconds. Now look at this. Here's my year. 8 means 1908. 12 means 1912. Y'all with me there? We can all count by 4. We're good. All right. Here's the time in seconds. Now, all I'm going to do is I'm going to create a plot, and we'll go over this code, but you guys are pretty familiar with plot at this point because we did the data visualization section. Tell me what's going on. Positive or negative relationship?
Negative.
Negative relationship. All right. What's it mean? We can identify the statistical concept, right? That's a negative relationship. Awesome. I listened. Now tell me what it means. People getting faster or slower?
It's
Faster.
decline.
Somebody said faster. Somebody else said something there. I couldn't hear you.
It's declining.
It's declining, which means people are getting faster, right? Dash times, the winning time is decreasing as time moves forward, right? As time increases. So it is a negative relationship. But the other thing we're seeing, right, is that people are getting faster. Like, that's the takeaway. It is a negative relationship. What's that negative relationship to me? It means people are getting faster over time. These dash times are getting faster. Y'all with me on that? From a boardroom perspective, your eyes go to that's a negative relationship. You never say that again. You never go, yes, this is a negative relationship. They don't care. You're going to confuse them right off the bat. What you say is, hey, look, as time increases, people are getting faster. It's our job to know how to leverage that negative relationship. It's their job to understand what it actually means. Y'all with me there? Like I said, interpretation ain't going anywhere. Get used to it here. Now, numeric or the visual summaries are great. What we need to talk about now in numerical summaries, and this is the part you guys asked me to cover, and this is the part I want to make sure we hammer a little bit, which is what is correlation. Now, you all use this in everyday speak to say there's a correlation between these two things. What you're getting ready to figure out is my biggest pet peeve. Correlation is a statistic. It defines the strength of a linear relationship. All right. A lot of people use the word correlation where they should be using relationship. Y'all with me on that? Y'all don't be those people. All right. Now, scatter plot allows us to eyeball the strength of a linear relationship between two quantitative variables, but we also need to quantify, all right, the strength of the relationship. We need to put numbers on this stuff. Let X1, X2, Xn, and Y1, Y2, Yn denote two paired samples of size n. Let me say that in a non-mathematical way. X1, production for movie 1. Y1, box office sales for movie one. X2, production costs for movie two. Y2, box office sales for movie two. Y'all with me there? That's what we mean when we say paired. X always is what we're going to call a predictor or the independent variable. It's the thing we can set. The Y is the dependent variable, the thing we're going to look at the result of, right? Think back to your 8th grade science class where you talked about independent and dependent variables, right? X is the independent variable, what we call a predictor. It's the thing we can control or the thing we observe first. Y is the dependent variable, or what you're going to hear me call a response. Okay. Why is it response? It's our outcome. It's the thing we're worried about the most. You guys with me there? Predictor, response, independent, dependent variable. Everybody with me? If you ever get confused on it, hey, Brad, what's that mean again? Real quick stop, okay? Now, also let X bar be the mean of our predictor data. Let SX be the sample standard deviation of the X data. Y bar be the mean of the Y data, and SY be the sample standard deviation of the Y data. The reason I show you this is because if we have two predictors, everything is based on mean and standard deviation. All right. Y'all with me on that idea? Nothing I'm getting ready to show you is more complex than a stat 101 calculation of mean and standard deviation. It's just the way we utilize them together. Y'all with me? All right. Correlation, or what is also called little r. Correlation is a measure of strength and direction of the linear relationship between two quantitative variables. The sample correlation between two variables X and Y can be calculated using this equation. Now, here's what I want to show you. All this is based on data minus the mean divided by the standard deviation times data minus the mean divided by the standard deviation, summed up over all possible observations. So think of this as production value minus the mean of production value divided by the standard deviation of production value for every movie. Notice these I's pair. So we're multiplying these two quantities for the same movie. We're summing them up over all observations. Now, here's two things I want to point out to you, and these are kind of important. Notice what the question this is really asking is, how far is this from the mean? How many standard deviations is data point Xi from the mean? Xi minus X bar divided by the standard deviation. That's what we call a T statistic or a Z statistic, depending on who you've learned that from. But what you're doing is asking the question, how far is this from the mean? And think about it for the sign for a second. If Xi is below the mean, what's that? That's negative, right? Numerators, positive or negative. Is it above or below the mean? This asks the same question. Is the associated Y variable above or below the mean? Basically, what we're seeing is those negative relationships that you identified will have a negative sign in correlation. Because what we say is if X is above the mean, Y will be below it if the association is negative. If the association is positive, we expect more times than not, if Xi is above the mean, Y is above the mean. Let me prove it to you. We're going to keep going back to these plots a few times. You guys will get tired of them. I apologize about that, but I want to make sure we drive some of these points home. Let's call that the mean value of Y. Call that the mean value of X. Y'all with me there? So where they cross is the mean value of X and Y, right? Now take a look at something for me. If I say X is above the mean, which means I'm going this direction, is Y above or below the mean? Look at your data here. If X is above the mean, if we're working above 30, does Y fall in the top box or the bottom box more often than not? Falls in this top box, right? So what that's telling me is if X is above the mean, Y is also above the mean. That's how we identify the positive correlation. You guys said that was a positive trend, right? It says both those things are moving in that direction. Okay. Now take a look here. That's the mean of X. That's the mean of Y. If X is above the mean, where's Y? Top or bottom?
Bottom.
Which means it's negative relationship. That's how that calculation works. Now, the reason I want to point this out to you is because your eyes and your terminology will also identify the sign of the correlation statistic, okay? That'll tell you whether it's positive or negative. When we say positive association, what we're really saying is there's a positive correlation, okay? When we say there's a negative association, we're saying there's a negative correlation. Visually, that's how you guys detected it. Mathematically, it's also how it works, all right? So the math matches your intuition. Now, y'all got to know me by now a little bit. You think we're ever asking you to calculate a correlation by hand? You think I think that's a good use of y'all's time? You think it's a good use of ours grading it? But you better understand it from a conceptual level that visually it's going to match the sign. If it doesn't, you got other problems. And I'll show you that here in a second. Y'all with me there? Now, let's keep going. Some properties. The value of R does not change if we reverse the roles of X and Y. If you flip them, correlation is still the same number. The value of R does not change if we change the units of the variable, i.e. converting pounds to kilograms. It won't affect it. It's still the same relationship. Why? Because it's based on means and standard deviations. It's what we call a standardized statistic. R only measures the strength and direction of a linear relationship. It measures straight lines, not curves. R is not resistant to outliers. Why? It's based on means and standard deviations, not medians, right? It's a function of a mean. We know means are not resistant to outliers, right? You get an outlier in your data, you take the average, it gets inflated or deflated depending. R's are always between -1 and +1. Now, R greater than 0 is a positive association. R less than 0 is a negative association. R equals 0, there is no relationship. Now, here's some ways people talk about strength. We ain't those people. All right. Feel free to use this if you want. You'll never hear me say this type of stuff. You'll hear me say a statement of what it is and say, you know, yeah, that's a positive relationship and it doesn't have much variability to it. Now, let's come up here and let's talk about these numbers. The closer to 1 or -1, the stronger the relationship. Correlation right here, 0.934. That's pretty close to 1, right? So if you're using that terminology down at the bottom of the page, you'd say that's a strong linear relationship. But let's compare it to this. Here's a correlation of 0.377. Out of the two, which has a stronger linear relationship? Top or bottom? Top. Closer number to 1, the stronger the relationship. Y'all with me on that? So really, all we're saying here, closer to 1, better off we are, or stronger the relationship. I won't say better off we are. Now, visually, you all are always going to be looking for stuff like this. Okay? You all are always going to say, no, it's got to have the 0.9 correlation. Practically, this about the size you're going to see. Real world and textbooks don't align a lot of the time, y'all. Part of the reason I like teaching classes like this, because we're going to work on some stuff that is real. You're going to run into these situations. What you do and how you interpret it matters. It is not your job to try and fix that data. It's your job to report on it. Y'all with me on that? You are there as an analyst most of the time, which means it's your job to say factual things about what's happening. If you're asked for interpretation, give it. But make sure the fact comes first. Y'all there? Now, next piece. We said this was a negative relationship, right? Ooh, negative relationship. Negative correlation, 0.78. Chris, you've got your hand up. What's up?
What would be the case in terms of having missing data, like an incorrect data? How would that affect the correlation?
Having incorrect data, garbage in, garbage out, makes your analysis, any analysis you do, useless. regardless of the statistic. Outliers will have some effect, and we'll talk about those as we go through, but it's your job to tease out what that effect is, because the things you think are outliers or missing data is missing data. Like there's a million ways to adjust for it, and we'll talk about some of those. But again, outliers are a different beast, and you've got to correct for them. The only way you remove an outlier from any type of analysis is if it's not from the same trend. And I'll give you guys examples of that when we go over it. Does that make sense?
Yeah, thank you.
Awesome. Last thing I want to show you. Remember, you've heard me harp on the statement linear relationship, right? Linear means straight line. Let me ask you this question. Is there a relationship between Y and X in this plot? I did not say linear. Is there a relationship? Everybody agrees there is a relationship, right? Yes?
Yes.
All right, awesome. The correlation is 0. Correlation is very good at detecting linear relationships. It is not good at detecting that relationship. I think we can all agree. Y'all right with me on that? You understand my problem with people saying these things are correlated now when they mean related. Correlation is a very specific thing. It's a very specific term. Yes, that is me being a statistician and being crazy about how people speak. And you all know what they say. I know I'm not the most articulate person on the planet, but when we're talking about data, we have to be careful. Y'all with me on there? By default, start saying there is a relationship between two things rather than correlation. Y'all with me? All right. A couple other things as we go here. That's correlation kind of in a nutshell. If we look at what's going on here, just to give you a feel for what's happening, if I go back up here and I look at my 200-meter dash times, automatically we're expecting that to be negatively related, right? We said that was a negative association, so we think there's a negative correlation, right? So when we calculate it, and we'll calculate it in R, and I'll show you guys how to do this a few times. When we calculate between year and correlation, if we treat this as X and the other one is Y, it's the same as the correlation for time and year. What it's doing, y'all, is just calculating the variables. If you flip this equation, if you change these, the multiplication remains the same. All right. So again, when we're talking about relationships, it doesn't matter which is the response. When we're talking about correlations, it doesn't matter which is the response, which is the predictor, which is the independent or dependent variable, however you want to think of it. It just matters, is there a relationship or not? Okay. Now, let's talk about regression a little bit. Correlation is the foundation of regression, and I want to take 10 minutes here and get you guys introduced to regression. What you will figure out is regression is my favorite topic because it sets the foundation for all machine learning, whether you realize it or not. This is the base of all prediction methods. This is the base of all machine learning and artificial intelligence methods. So right now you can say, hey, I'm learning machine learning. Awesome. Because that's the way we're going to talk about it. That's the way I think about it. That's the way we're going to talk about it. I'll walk you through some of the inference and the interpretation stuff. But at the end of the day, that's where this stuff's foundation is. Correlation provides the strength and direction of a linear relationship. We'll now learn how to use what we call least squares regression to provide a numerical description of the pattern of the linear relationship between a quantitative explanatory variable and a quantitative response variable. So independent, dependent, you'll hear me call this predictor, okay? It's a predictor. It's something we know to make a prediction, all right? A regression line formulates the linear relationship between a response variable Y and an explanatory variable X and can be used to predict the value of Y for a given value of X. Basically, what I want to tell you, go back to my original example, is, hey, we're going to spend this much in production costs. How much should we expect to make at the box office? Would you all agree that's a prediction problem? What we're going to do is we're going to make Y box office sales and we're going to make X the production costs. And what we're going to try and set up, what we're going to do is try and set up an equation that allows me to predict one for the other. Y'all with me on that statement? That's all it is. All right, so let's talk about it. Suppose we have an explanatory variable X, so a predictor variable X and a response variable Y with observed data pairs. So this is box office sales, which is Y1, and production costs X1 for the first movie, clear up to the nth movie. So in that original example, we were 10, or we can talk about the 200-meter dash example and say X is the year, Y is the time, right? Why would we want a prediction there? Imagine you're an Olympic runner training for, when we running that again, 2024? The 2024, the COVID year threw me off. I don't know how they're doing that sequencing now, but let's assume it's normal when we go to 2024, right? You want to know what time you're going to be expected to be. Does that make sense? If you're a coach, if you're a trainer, you want to know your target time before you set it. Y'all with me there? So again, keep this in mind as we go. Now, let's talk about this equation a little bit. Put some definitions on some things. Let Y hat be the predicted value of Y when we know X. We call that thing Y hat. See that little thing on the top of that little caret? We call that thing a hat. All right. Now, let alpha, I want you to go back to 8th, 9th, 10th grade. Whenever you learned your algebra, you learned Y equals MX plus B as a line. That's my guess, right? You guys remember that? That's all we're doing here. All right. We're just using alpha or A and B. Okay. A and B for right now as your y-intercept and your slope. A is the intercept. It's your y-intercept. The value of y when x equals 0, but may not have any interpretive value if no observations have x values near 0. Now, let's talk about that for a second. We're talking about our movie example, right? Production costs versus box office. If you have production costs that are $0, do you have a movie? So we can all agree that we cannot have a movie, at least conceptually, with 0 production costs. You had to buy something at some point to film the movie, right? So what we're saying here is we'd never observe a data point at x equals 0. That doesn't mean the line doesn't have an intercept. We have an intercept. Things run off to infinity. That's the beautiful thing about a line. It keeps going and it keeps going both directions. But we just may not have data. All right. B is the slope of the line. Now, if you all learned it like I did, we called that rise over run, right? Rise over run. How much does something go up and how much did we move? Y'all with me on that idea? So again, what we're talking about here is how we interpret these parameters. These parameters are really, 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 really important because they're what give us insight about what's actually happening in the data. Now, if I want to come down here and start thinking about this, what we're doing is we're thinking, what does this look like on a graph? Whatever that point right there is, where this thing crosses the x-axis, right? Or this thing crosses the y-axis. So when x equals 0, that's A. The distance here, let's say this is 1. Say that is length 1. This is B. All the slope is, it says, look, if I take X and move it 1 unit, how much do I expect Y to go up? That's rise over run. All A is where does it cross the Y-intercept? We may not have data there, so we're going to interpret it that way. All right. Now, the relationships between the correlation coefficient and B. All right. And the slope. If B is greater than 0, there's a positive slope and a positive association. Therefore, if B is greater than 0, R is greater than 0. And the other way is true. If R is greater than 0, B is greater than 0. All right. Similarly, if B is less than 0, R is less than 0. Now, let's start with prediction because it's the easiest thing to wrap your head around. Suppose we have a regression line with A equal to 2 and B equal to -1/4. We're going to write down the formula and draw a picture of the regression line. All right. Formula is y hat equals 2 minus 1/4 times x. I just plugged everything in, right? Told you what my intercept and my slope were. Positive or negative association. Remember, what we're looking at is the sine of b for that, right? Slope is negative. Y'all with me there? All right, so let's draw the picture. Slope's negative. What's the y-intercept? Y-intercept right there is positive 2. Yeah, that doesn't look like an arrow. That's positive 2 right there. All right, where we cross the x-axis. That's what our model looks like. It says we're going to decrease for every 1 unit increase in x. We're going to decrease by negative 1/4. Or we're going to decrease by 1/4. Now, what I want to do is I want to predict y for x equal to 100. What do? We throw 100 into the equation. We say 2 minus 1/4 times 100 is negative 23. You want to predict y for 4? 2 minus 1/4 times 4 equals 1. 1/4 times 4 is what? 1. 2 minus 1 is 1. This is all R and TI 83 stuff. What I need you to understand is when we come up with any type of line, we can throw a value in for X. That's a prediction. Y'all good with that? Moving on. What we've got to do now is figure out how we're going to come up with a slope and an intercept. We got to figure out how we're going to come up with a slope and an intercept. Specifically, I've got all this data. How do I come up with a single slope and a single intercept? And we're going to do that on Wednesday. All right. Any questions? Again, I know this is kind of an elementary review to begin with, but you guys told me you wanted to review some of this stuff before we got into the more technical. So right now, I'm just making sure we understand concepts, and we're going to come back and hit this hard with R code and data after fall break. Y'all good with that? This useful, boring, crazy? We'll turn off the recording. I'll ask that again here in a second. Any questions? All right, remember, we've got a visitor coming in for a little bit on Wednesday. We'll get back to this and keep going through this, okay? If y'all need anything, yell. More than happy to chat, more than happy to talk, more than happy to walk you guys through whatever you're missing, okay? Again, if there's something you think you should remember from another class and don't, we're here for that too. Y'all with me? Guys, have a great week. We'll see you Wednesday. Stay safe, stay healthy.
Bye, everyone.
I have one question, or I have two questions about material. Does anyone have about 3 minutes to answer them?
Yeah. What's up?
Okay,